The atom is the most basic component of all matter in the universe and can be subdivided into three different particles: the proton, the neutron, and the electron. The proton has a charge of +1 and has a mass of 1 AMU, which is roughly equivalent to this many grams, aka a really, really tiny amount. The neutron has the same amount of mass, but has no charge. These particles make up the nucleus of the atom, around which the electrons orbit. Electrons are much smaller than the others, with a mass of about 0.0005 AMU, and have a charge of -1. There are 118 different atoms, which are called elements. The number of protons in the nucleus determines what element the atom is. For instance, hydrogen has 1 proton, helium has 2, lithium has 3, and so on. The elements are organized by atomic number on the periodic table, which also shows the average atomic mass in AMU, which equals the number of protons plus the number of neutrons, and which elements have similar properties. For instance, column 18 consists of gaseous elements that do not typically react with other compounds. These are commonly referred to as the noble gases. The number of electrons orbiting the atom depends on how many protons are in the nucleus. The electrons are organized into shells, and each shell has a different number of electrons. The first and innermost shell has 2 electrons, the second has 8, and so on. In fact, you can tell how many shells a particular element has just by looking at what row it occupies in the periodic table. As a quick tangent, the electrons do not orbit the nucleus the same way the planets orbit the sun. Rather, they occupy what are called orbitals, but we'll discuss that in a different video. Also, the nucleus is way smaller than the models show. Basically, all those diagrams from your middle school science class have been lying to you. Anyway, let's continue. The outermost shell of an atom is called the valence shell and contains the aptly named valence electrons. These electrons are what allow atoms to interact with each other and form bonds, and the number of bonds that an atom can form is dictated by the Octet Rule, which states that an atom needs 8 valence electrons to be stable. Let's use nitrogen as an example. Nitrogen has 7 protons, meaning it has 7 electrons, 2 in its innermost shell and 5 in its valence shell. To fill up its valence shell, it will form 3 bonds with other atoms. It is also very commonly found triple bonded to other nitrogen atoms. We've talked a lot about protons and electrons, so now let's talk about neutrons and their significance in chemistry. While every atom of a particular element will always have the same number of protons, the number of neutrons can actually vary from atom to atom. For example, the most common form of carbon is carbon-12, which has 6 protons and 6 neutrons. However, a rarer version of it exists called carbon-14, which has 6 protons and 8 neutrons. These different versions of the same element are called isotopes, and they can have a significant effect on chemistry, especially nuclear chemistry. As an example, let's look at uranium-235 and uranium-238. Uranium-235 has 3 less neutrons than 238's. However, it is more fissile, meaning it is easier to split apart and releases a lot of energy. This makes uranium-235 much more valuable as fuel. However, natural uranium deposits have very low levels of uranium-235. Therefore, uranium must be enriched so that the concentration of uranium-235 is around 20%. In order to make nuclear weapons, the concentration must be much, much higher, at around 90%. I'll go further into detail in a future video, but for now we're going to wrap it up. To recap, in this video we discussed protons, neutrons, and electrons, and how the interactions between them form the basis of chemistry. I hope you all enjoyed, and I'll see you next time.